Okay, so we are first going to run the pedal feature extraction code, right?
Yes.
So for this, the command line argument is the directory containing the APK files, and the expected output is first we need to create a feature files here, right? In the current working
Yes.
directory, we need to create a feature file,
Yes.
and we need to give as input the location where we have the APK files. That is what
Yes.
is dot dot slash dot dot slash
Yes.
data set slash pedal, right?
Yeah.
Okay, so now we have three APKs in this folder,
Yeah.
and what we expect is like uh, the feature files for every individual package.
Yeah.
Okay, can you run this? Yeah, now it's disassembling by using APK tool and
Yeah.
then extracting the features for every single package inside the application.
Yeah.
Now the second application is being done.
Yeah.
Now the third. So is there any multiprocessing version, or it's always single processing, single CPU?
Single CPU.
Okay, so but also it can be trivially parallelized, right, by
Yeah.
using MP. Okay, at the moment we are just using one individual application disassembled at a time, right?
Yes.
Okay, so now can we check one of the feature files? It should be
Okay.
inside VI features. Okay, ls. The naming convention is like name of the application underscore name of the package dot features, right?
Yes.
Okay, can you just open one file for reference? Okay, so this one contains the visual elements, stemmed keyword, and then finally it will have some information about the source, sync, components used, internet access, permissions, and all those things.
Yeah.
Alright, so okay, so now for every individual application, these kind of files will be generated.
Yes.
So our next task is a manual task.
Yeah.
We need to look at each of these feature files and put them into two bins. One is add library bin, the other one is the non-add library bin.
Yeah.
So for that we have manually identified 190 add library related packages, and we have got the features for those packages. Uh, okay, I have a question here. Like, if there are 190 add libraries, the number of feature files may be more than that, right? The number of add libraries is not equal to the number of feature files, right? Because let's say here, if you see Google Android GMS is there, right? GMS, let's say for example, GMS internal and location both are belonging to the GMS add library.
Yeah.
Okay, in that case, we need to put these two feature files inside the add library.
Uh.
But it doesn't mean there are 190 add libraries.
No. Actually, the thing is, we will combine all the features to its parent
We
folder.
are not supposed to do that, right?
No. The we cause for individual subfolder, it can or cannot be a library. What I mean is,
No,
no.
each subfolder includes all its subfolders contents as well.
Yes.
So if I say Google GMS is an add library,
Mm-hmm.
then it will always contain Google GMS internal features, location features, maps features, and all
Yes.
those things.
Yes.
No, it cannot be right, because certain add libraries may not have a root folder with any smalley files, but individual folders may contain. Uh, what I'm trying to say is, let's say there is a case where you have Google Ads as a folder,
Mm-hmm.
and there is no smalley file inside that.
Yes.
Okay, no smalley file, but there are two folders: Google Ads internal, and then let's say Google Ads, and then ad delivery.
So the Google Ads cannot be a package,
Yes.
cannot be a valid package.
Yes.
So it will not appear in our package list.
Mm.
So it cannot be a ad library.
Okay, but what I'm trying to say is, let's say the ad functionality is split into two of its child folders.
Yes.
And each one of them standalone is not an ad library.
Yeah.
But they put together is an ad library. We do not have a scenario how to put them together, right? Because Google Ads itself is not containing any smalley folders.
Yes.
How do we handle this?
Uh,
How do we label them?
In this code, we can label them as both negative.
Then it boils down to say that we can only make a folder as an add library if it contains at least one smalley file directly under it.
Yes.
In any other case, it cannot be done.
This is according to the author. So previously you give me a large data set containing a lot of libraries, but it turned out to be a lot of empty package, which yeah, the the folder should be a library, but it contains no smiley file, so it was labeled as negative.
Okay, so in the paper there are certain examples, but the examples seem to suggest not what we are speaking of now. Anyways, we cannot do anything about it now, but this is how your code works, right?
Yeah.
Okay, your code assumes that all add libraries will contain at least one smiley file directly under their root
Yes.
folder.
Yes.
If not, then there is no way that it will figure in the positive samples.
But we also can
Artificially
label
put
some part of this library.
How?
Cause like for this case, if we classify with this many feature files, the google.android.gms.internal can be labeled as an
Add
library.
library.
Yeah, but it not appear in the author's whitelist.
Okay, so can you show me some examples that are inside the add so that I can see inside the add folder?
Inside the add folder. Okay.
CD add. Okay, not the Google ones. Do you have anything in Google? Just ls grep Google. Okay, you have GMS and also Google Ads. Both are two different. How do you manage to get the Google Ads features? Because Google Ads might not contain any smiley files, right? But some application contains.
Yes, yes.
Can you open that file? Let's see. I mean, can you vim diff these two? Vim diff, VIM, continuously DIFF, and then these two files. Can you go down? I mean, just rapidly down. Let's see. There's any wide difference. Yeah, there is, right. Okay, no problem. So you just leave it as such. Close this as well, and then okay, now Pedal feature extraction is done. We got the features files.
Mm-hmm.
Now we need to train and make the model, right?
Yeah.
Yeah, for that we are going to run Python pedal training, right?
Yeah.
Pedal training. So the input to this is two directories. One is the positive sample directory
Yeah.
and the negative sample directory. And the third input is like what is the extension of the files that we want to use as features for pedal. And the fourth argument is the feature binary bitmap. Like there are 6 sets of features, so we want to use feature set 1, 2, 3, 4, 5, 6, then we give 6 ones, like what you do now.
Yeah.
And if you want to exclude any one of those set of features, then we can put a 0 there.
Yes.
The 6 set of features seem to be visual elements, components, permissions, keywords, stemmed keywords, and then whether there is real-time permission check or not,
and API.
and APIs and internet usage, something like that.
Internet usage is not one
Individual
type of
category.
yes, according to the author, but we use internet access to final check whether this package is a library or not. It is not appeared in classification portion, only
Okay.
in the last.
For
function.
pruning the results of the
Yes,
classification.
yes.
Okay, fine-tuning the results of the classification.
Yeah.
Okay, so now we try to train them by using the add and the non-add folder inside the training data folder. Yeah, you
Yeah.
just hit enter. Now we are using several things happen here. We loaded 190 add libraries, 244 non-add libraries. These are dot feature files that we manually collected. So this is kind of, a very manual, very time-consuming and a laborious process.
Yeah.
We need to go through all the disassembled outputs of every individual application,
Yes.
determine whether it's a positive or negative sample, and then put them into these two folders.
Mhm.
And once this is done, we go for feature extraction by using binary feature.
Yeah.
We have to do binary, but in this code we are doing TF-IDF, which
Yeah.
will be replaced later to binary.
Okay.
And also we are having this kind of 70-30 for training and the testing portion.
Yes.
So this will fit the model based on cross validation. No, not cross validation. It will directly use an RBF SVM, right?
Yeah.
It will directly use the parameters that are given in the paper and fit an RBF SVM, and use the fitted RBF SVM to classify the 30% of test samples and produce the results. And finally, it will also fit the model on a 30% test data only, and then dump model.pickle file. So the output of this is three files. One is the model.pkl, the one that we see in the last, and then we see the training report, in which we have the results for the 30% randomly chosen test set, and finally the vocab as well. The vocab is like, can you highlight the vocab.txt file? Yeah, so with this we can see, inside the vocab we will have all the features present across all the add and non-add libraries, right?
Yeah.
Okay, how many are there? Like, can you just do the :cnu colon, no, just close this. Yeah, wc minus l vocab.txt. L, yeah, vocab.txt. Yes. So it contains only 213 features. So this is going to be a very small set of features, right? Okay, so this is how Peral, this is the total number of features that are extracted from all the samples. And each package in this scenario becomes a 213 dimensional feature vector,
Yes.
right?
Yes.
Okay, now we have this model.pickle, which is fitted only on the 30% data, and it will be later replaced with fitting on the 100% data, and we will use that for classification in the further tasks, right? So this model is going to be for this fixing this, we are going to do np stack of the training and the test samples and use them to fit inside the Peral training.py. Okay, now I think probably we can go for Peral test.py.
Okay.
So now in the Peral test.py, what are the inputs and what are the outputs?
The first one, the input should be a set of applications to be detected, and the output is a text file for each package, which contains the top features of this package, and another text file for each application, which is the detected libraries for this certain application.
Okay, so there will be the add libraries identified inside one application will be one file,
Yeah.
but for each package of each application we'll have a separate file.
Yes.
Okay, so those are the outputs.
Yes.
Two types of outputs.
Yes.
Okay, so we can see on the three applications that we have inside the demo dataset. Yeah, demo Peral, right? Dataset Peral. Yeah. You made some changes, right?
Yeah. Actually, previously I made something wrong with the location.
Okay. If there is any change in the code, you please check in from here
Yes.
itself, right? Okay. So the vocab.txt, after that we will give the bitmap of the features. Now the argument seems to be like the folder that contains APKs and then the classifier that we want to use and the vocabulary on which we want to fit the test data
Yeah.
and the bitmap of the features that we want to use. The vocab is very important because we can edit the vocab to remove or to add new features that we want to extract from them.
Yeah.
But I think addition is not possible, right? Only removal is possible
Yes,
because
only remove.
the classification may go wrong. But for removal, we can also use the bitmap to exclude certain type of features. For example, if we don't want the visual elements, then we can put a 0 first and then followed by five ones, right? Okay. So now it's disassembling the first application and then it should run the feature extraction for that. That's what is happening now. Disassembling the second application, third one. Okay, now all the detection is finished.
Yeah.
Okay, where will be the output placed?
In some
Current working directory.
Yeah.
Okay, so
it's-
let's open. Okay, let's make a new directory and move this output there so that it will be very clean.
Okay.
Like mkdir pedal output, something like that. Now can you move all the top fees.txt. Top fees. Pedal out. Yes.
And also
ls minus lit.
also yeah.
Okay, so first we see what are the libraries inside Butterfly Live wallpaper. Yeah, just get it. Okay, there is only one ad library inside that. Okay, now what about other applications? Can you just cat star adlib? Yeah, cat star adlib.txt. Yes. So many ad libraries are identified. Can you go up? Let's see how many are there. No, just put up arrow pipe LC. There are so many. No, I think it's displaying everything. Isn't it? No, you just give me the keyboard 1 minute.
I think it should in capital.
Capital ladder. Oh. Okay, first one is Butterfly Live wallpaper and it contains only one ad library. The next one also contains only one ad library. Emoji contains only Umang Analytics. Is that an ad library?
Yes.
Okay, the third one contains Google GMS and then Android. But apart from that, there are no ad libraries at all, right? So this is what we can see. Only 1, 2, 3, 4 ad libraries identified from 3 applications. So let's go and check what is originally present inside them. Like dataset from here, right?
Yeah, data set.
Dataset, right? And then we go to pedal. Disassembling the three applications, right?
New.
Okay, so ours actually identified GCM internal as add library, but there seems to be GMS adds here. This is an add library which is not identified by the pedal code that we have, and also yeah, only one add library is there. So is it actually identifying the correct one?
For this application, I checked with the out feature files. It should be right.
What is the name? Comdot?
Dot.
Singapore MRT. Oh, it identified two add libraries, GSM internal and then Android. But from here we can see Google Ads is missed. Oh, GMS is marked. So it is considering the entire folder. Okay. So GMS is marked as add library means it identified Google as well, right? But it falsely identified all of them as add libraries as well, right? Is it right? The way I interpret the result. It says GSM internal. Oh, okay. So which means only this one is an add library and not all these, right?
Yeah.
Okay. How about Android? This one is marked as an add library as
It's
well.
not this Android. It's the Apple one.
Where is the upper one? This one.
Yeah.
Oh, come on. How this entire thing becomes add library? I don't know. I think probably this is because we are fitting with 30% data, right?
Yeah.
Did you modify the code to include the 70% data as well?
No, not really. Not yet. But previously, the only output is the first internal. I have not seen the Android things before.
Yeah, let's check the next one.
Okay.
Okay, so this one seems to be quite a large application. There is Google Android GMS ads, and there seems to be only one library to me. Let's see what Pedal says. GMS internal. Where is GMS internal? Yeah, GMS ads is missed, but GMS internal becomes an ad library. Okay, so it seems kind of mispredicting most cases. It's not going to give us any good accuracy, I think so. What about the last one? Oh, what the hell is happening? Okay, in this Umang Analytics is identified as an ad library by this tool, but yes, there seems to be no ad library. So there are false negatives as well as false positives. Somehow. Yeah, so anything else that we need to note? From Pedal's end, or we are done with Pedal?
Yeah, maybe I will fix with tweaking all the features and see the output. Apart from that, I think none.
Okay, so we can for the moment conclude the Pedal demo, right?
Yeah.
Okay, I stop recording for the Pedal now.